Okay, let's continue with the next part of this notebook, optimization and training. So here it's just a theoretical discussion on how you update the weights of your network to train the network to get a better result. And there is this formula. It's in a very small font, at least on my screen, again like all the formulas in this notebook. So we have the theta, this large theta, which is the weights, and we in the learning process we update the weights. So we have the weights of 1 at one time t, and then the weights at t plus 1, which are the updated weights theta. And which components go into the update? First of all, the loss, which we already discussed. So how much difference is there between the predicted value and the label? Then the gradient, which is the delta on those thetas. So in which direction should we update the weights? And finally we have a learning rate, which just defines on how big your step into the direction of learning should be, which is a hyperparameter which is important on how fast the network learns. But if you set it too high, then you may overshoot, you might go into a wrong direction in learning. And finally, in this notebook we look at a practical result on or a practical example on how to implement a very simple classifier of documents. So please again read the text, but the basic idea here is, if we look at the code, that we want to classify input documents into two classes, whether the document is English or whether it is Spanish. So here we have 4 training documents, 2 in Spanish and 2 in English, which we just split into words, and then we have 2 testing documents, which we will then use at the end to see if the classifier learned to classify documents into English and Spanish. So there are multiple steps involved into building this classifier. We use here a bag of words approach, and as you remember from other units, bag of words just basically means that you have a vector which just has the counts of your words in the vector, and every item in the vocabulary, so every different word, has one place in this vector. So to create this bag of words representation, we first need to make a dictionary which has the mapping between the words and the indices in the vector which represent the words, which we create here. This is also the same. This vector has the length of the vocabulary. So the length of the vector is the vocabulary size, and then we know that the number of labels in our problem are 2, English and Spanish. Then here, as a next step, we create this class for the classifier. So this is our PyTorch classifier. It's based on the basic PyTorch module. It has an init function which is called the initialization of this classifier, and here we, as the main part, we define a linear layer. So there's only one linear layer in this classifier, which maps the input, which is of size vocabulary size. This is the input vector. It matches it to an output vector which has size 2, as this is the number of classes which we will get. Then it has a forward function, which is called on when we pass the input through the linear layer. So this is the function that is applied to our inputs. So the inputs are these bag of word vectors. On this input we apply this linear operation, and then finally we apply some softmax operation to get the probabilities for the output. So this is already the class for the classifier, and then we have some more helper functions, like transforming a sentence into a bag of vector representation here, another function to just get from target labels to a tensor which represents the labels. So we have one label for English and one for Spanish, then in the format of a tensor, which is then used for computing the loss. Now we can create, we can instantiate the classifier, which is given the name model. Then here they print the parameters of the model, which in the beginning should be just random numbers. So we can have a look down here. So these are the parameters, it's just random. And finally we do one test. We classify the first input data, sample data at index 0. We make it into a bag of words representation. We compute the probabilities and print as probabilities. And this is the output probabilities, and as we now in the beginning did not train the model yet, those values also should have no meaning, so they are rather random, and they are also rather close together, so the classifier does not yet know if the document is English or it is Spanish. Okay, so after we have defined the architecture of our model, here we just create a mapping from the language labels to numeric IDs, which we will need for the training. And we'll now look at the training process. Okay. Please again read the text. But we'll look at the code on a rather abstract way. Okay, so first they just applied the model to the test examples, but before we train it, so just to see that before we train it, the probabilities created by the model for the test examples are pretty much random, and after training we should get some reasonable probabilities for the test examples. And then we also print the parameters for a specific word, Spanish word, to see before training and after training how those parameters change. Good, then we define the loss function. So the loss function, as you know, is used to compare or to have a quantification of the difference between the labels and the predictions. And then we have an optimizer which tells us in which strategy, which way we update the weights in our model. And also here we define the learning rate, which is used in the weight updates. Okay, and then we have the most interesting part, which is the training itself. So we train for 100 epochs. In this example, we go over all the instances and the labels in the data. So we loop over our input data. Then in the first step, we have to call this zero grad to just empty our gradients, which is necessary, else they will be accumulated. So we just need this command. Then in step 2 we just make tensors from our training data and from our labels for the bag of words vectors and the targets tensors. Then we compute the probabilities on the input, which is the output log probabilities here. Okay, and then finally we can do the training. We compute the loss in this step. We call backward to do the backpropagation, and we call this optimizer to update the weights in the network. Okay, so this then runs in this big loop over 100 epochs. So we go 100 times through the training data and update the weights of the network. And then finally we can run the prediction on the test data again to see if now we have better predictions than in the beginning. So we don't need to look at the code, it's the same code as before. We can look at the results. And yes, I think this was the first Spanish test document before training, so we have not so much difference in the predictions. And then after training, it is this first number is the probability of Spanish, and this other one is for English. So for the first document, which is Spanish, it has now a much higher number for the Spanish class, and for the second document, which is an English document, it has a much higher number for the English class after training. And also if we look at the Spanish words, how the weights are for the words when we connect it to the output classes. So yeah, before training we just have weights which were random and almost the same, and after training the Spanish word is connected to the Spanish class with a positive weight and to the English class with a highly negative weight. So you can see here in this simple example that even the single word, there's a connection between the Spanish words and a positive connection to the Spanish class and a negative connection to the English class. In a deep learning structure where you have a number of layers in the network, you don't have a direct connection between the input word and the output class. So there it will be not so easy to trace this connection. Yes. Good. This is the end of this video, and the end of Unit 6 lecture. Let's keep in contact. There is the group on Telegram if you have any questions. And one thing which I wanted to do is to give you a little example which you can work on for what we learned in PyTorch, which I will add also to this video in a second. Good. About the final example for this unit, let's keep it very simple. I think with the current knowledge, the best thing which you can do is just to modify the training data. You can add another class. For example, you can add Russian language, add some training examples and some testing examples for Russian language, train the model and play around a little bit with the things which you can change. That's the basic thing to practice this a little bit. This week there will be no homework. There will be a bigger homework next time about PyTorch. Else, I think that's all for Unit 6. I wish you health and the best, and if there are any questions, write me on Telegram or email, and I'll see you next time. Bye bye.